Hello, everybody. This is lecture number 6 of chapter number 7, and the title is Magnetic Charge. I will discuss about magnetic charge today, and I will I will try to explain that is it possible that there exists a magnetic charge. So I will use this in a Maxwell equation, and let's see what will happen. So the topic is magnetic charge. We find a pleasing symmetry in Maxwell's equations, particularly in free space. Free space means that if we have no charge, there will be no charge density and there will be no current density. So it means that rho will be equal to 0 and J, the current density, will be equal to 0 for a free space. If these are equal to 0, then what will be the Maxwell's equation for a free space? So the Maxwell's equation, the first one, we know that if rho is equal to 0, it means that the divergence of E will be equal to 0. And the second one, which is equal to minus partial B divided by partial T, that will be as it is. And the third one will be del dot B, which is equal to 0. And the fourth one, if I write down like this, the fourth one will be equal to, if J is equal to 0, it means that del cross B, which is equal to mu naught epsilon naught partial E divided by partial T. So these are the Maxwell's equation when there is no charge. If charge is absent, it means that the rho will be equal to 0, J will be equal to 0, and the Maxwell's equation can be written like this. Now, there is a symmetry between these equations. If we replace E by B and B by minus mu naught epsilon naught E. So this is the condition if we replace E by B and B by minus mu naught epsilon naught E. Then how the symmetry exists between these Maxwell's equations? I will put the electric field and magnetic field in these two equations, and I will get these two equations. Then I will put the value of B and E and these two equations, and then I will get these two equations. This is the symmetry between these four equations. First of all, let's see how this is possible. Consider this 1 and 2, del dot B, which is equal to 0, and this equation del cross E replaced by B and B replaced by this. Del cross E is replaced by B and minus partial divided by partial T B. I will replace this by minus mu naught epsilon naught and E. Del cross B, which is equal to minus minus plus mu naught epsilon naught partial E divided by partial T. I got this equation and this equation. So this one and this one. So this is the symmetry. Now I want to put the value of B and E in these 3 and 4, and I am interested to find out this one and this one. Let's see. I want to erase. Consider this. B can be replaced by E, which is equal to 0, and here B can be replaced by minus mu naught epsilon naught E, which is equal to mu naught epsilon naught partial B divided by partial T. E can be replaced by B and B can be replaced by this. Then minus mu naught epsilon naught del cross E, which is equal to mu naught epsilon naught partial B divided by partial T. This one and this one cancel out, and del cross E will be equal to minus partial B divided by partial T. So the same result, I considered 3 and 4 and I got the 1 and 2, this one and this one. Now let's consider rho m and Jm are density and current of magnetic charge, i.e. if magnetic charge exists, then one can consider magnetic density rho m and current density Jm, and let's suppose that rho e and Je be the electric charge density and electric current density. This statement means if magnetic charge exists, then I can consider rho m for magnetic charge density and Jm for magnetic current density. And if I label rho E as the electric charge density and Je is the electric current density, then how we can write down the Maxwell's equation? Then the Maxwell's equation then the Maxwell equations will be, the first one is del dot E, which is equal to rho E divided by, this is electric field, then it can have rho E epsilon naught, and del cross E, which be equal to minus mu naught Jm minus partial B divided by partial T. And the third one, this is the divergence of E, which is equal to rho E divided by epsilon naught. If magnetic charge exists, then divergence of B must be equal to this one. And similarly, the fourth equation, del cross B, which is equal to mu naught J E plus mu naught epsilon naught and partial E divided by partial T. If magnetic charge exists, then this will not be equal to 0. Here magnetic charge density will have take this form, and we can also have Jm, the magnetic current density. Then these equations are Maxwell's equation, and we can write down like this: F magnetic and electric charges are. In these equations, the symmetry will hold. If we put E by B and B by mu naught epsilon naught E, then these two equations can be converted into these two, and these can be converted into these two. It means that we will have a symmetry if magnetic charge exists. If the magnetic charge exists, then the continuity equation from the conservation laws, i.e. the continuity equation must be written like this. The continuity equation del the divergence of J, if the magnetic charge exists, then this will be equal to Jm, and this can be equal to minus partial rho m divided by partial T. And we know the electric one, Je, which is equal to minus partial rho E divided by partial T. So it means that if the magnetic charge exists, then I can write down the continuity equation like the magnetic monopole doesn't exist. We know about this. There is no magnetic monopole. It means that we cannot, this is not a true, and we have only this one. This is the reason that this magnetic charge, the topic is considered. And this is just a supposition. If you have a magnetic charge, then what will happen to the Maxwell's equation, what will happen to the continuity equation? So this was the topic related to magnetic charge.